All right, welcome to our lecture on the introduction to chemical reactions. Chemical reactions is something that we're going to study in depth this year in chemistry. It only kind of goes hand in hand, chemistry, chemical reactions. So we're just going to get a brief little overview of chemical reactions here, and we'll dive in to them more during this year. Let's take a look. All right, so we're going to start off with talking about what is a chemical reaction. And as you can see, my formatting from my PowerPoint to this program got a little screwy, so I had to kind of improvise a little bit. So I apologize for that. But we still have all of the pertinent information on this slide. So a chemical reaction is a process that leads to the transformation of one set of substances to another. All right, so we're starting with one set of substances, one set of atoms, and we're going to get a different combination in the end. All right, that is a chemical reaction. All right, it's represented by a chemical equation. All right, so this picture here shows a chemical reaction occurring. Okay, it is the process of leading the transformation of this guy here we call methane, CH4, and two oxygen atoms, or two oxygen elements, I should say, and rearranging them into new things on this side. We have new substances. We have, instead of the black being adjoined to the white like we had on the left side, now the black one is bonded with the red ones. All right, you see that? And instead of the white ones being on the black one, now the white ones are on the red one. So you can see we have a new combination or a new arrangement of these atoms from one side to the other. And that's the key for chemical reactions. We have to have new combinations on the other side. So the chemical equation then is this here. I'll highlight it in red. That is what we call the chemical equation. It's like a little shorthand way to represent what's going on in this substance. So in this reaction, we have methane reacting with oxygen to make carbon dioxide and water. Now, instead of writing out methane plus oxygen, like the whole words, we're going to use what's called a chemical equation and symbols. All right. So the symbol for methane is CH4. Okay. The symbol for oxygen, these red ones are together are called oxygen. Symbol for that is O2. Okay. The symbol for carbon dioxide, instead of writing out all of that, we can just do BAM, CO2, right? And hopefully the last one you guys recognize as water. Okay, instead of writing out the word water, boom, we can just write H2O. So that's what we call a chemical equation. It's a shorthand way to represent what's going on in a chemical reaction. All right, and then the last thing we're going to talk about on this slide is the difference between reactants and products. So reactants are always on the left side of the chemical equation, always on the left side, and that's what you start with. So chemical equations are always read left to right, just like we read books. And so on the left side, we have our reactants, what we start with. And then on the right side, we have our products, or what we end with. Okay, and again, this is always on the right side. So the right side and the left side have to have different symbols in order for a reaction to occur. Bottom line. We have to have different symbols on the left of the equation than we have on the right side of the equation. If we had the exact same thing, for example, H2O is a solid, and there's just a little arrow that says H2O, and now it's a liquid. Okay, that's an L, sorry. We can see that H2O on both sides, not a chemical reaction. All right, no reaction here. It is not a chemical reaction because there's not a new combination on the right-hand side. Okay, so that's what a chemical reaction is and a chemical equation. So in order to have a new arrangement and something new on our product side, we have to have bonds breaking and new ones forming. Okay, so that's going to be one of the keys that we're going to study in chemistry is the breaking of bonds breaking, and new ones forming. Okay, so breaking and forming are going to be topics that we are going to definitely take a look at. And we're going to take a look at the energy it needs to break and the energy released when new ones form. Okay, so we're going to tie in energy with the matter as well. Okay, so we can see that on our reactant side, we had to break these bonds between the hydrogen elements, right, in order for them to make new bonds on this other side. Okay, in order for oxygen to make a new bond between the hydrogens here. Okay, so we have bonds breaking in the reactants and bonds forming in the products. So break in reactants, form in products. All right, last but not least in this introduction is some evidences of chemical reactions. We're going to see many different chemical reactions this year. You're going to be doing many different types of chemical reactions. And so, but then you're also going to be doing some things that aren't chemical reactions. So we kind of, have to know the difference when we can tell something is a chemical reaction versus when it's not a chemical reaction, when it's just a phase change. So let's take a look. There's 5 different evidences of chemical reactions. So we know a chemical reaction has occurred if at least one of these 5 things happens. A lot of times it's a combination of these 5, but at least one of these 5 things has to happen. All right, so the first being a color change, and it's bold and underlined and italicized because there has to be a change in color in order for a chemical reaction to occur. Okay, if something, if we say, that car is red, that's not a chemical reaction. That's just an observation of what that car is. Okay, but if we said, hey, that car went from really bright red to really dull red, okay, then a chemical reaction must have occurred because there was a color change. It could be in a color change in the shade, or it could be a completely different color, like this one over here, where we had a yellow substance, and as soon as we added this powder here, it turned green. All right, so completely different colors. So a color change is our first evidence. Number 2, gas production. Gas production means bubbles, right? So we have, kind of gas coming out from our substances. A lot of times you'll see actually little bubbles forming on a certain substance, or coming out almost like it's boiling in a sense. All right, but boiling is a phase change, not a chemical reaction. So there is a bit of difference there. But in any case, if you add 2 substances together and you get bubbles, is definitely a chemical reaction. Number 3 is the formation of a precipitate. That might be a new vocab word for you. A precipitate is a solid that forms from liquids. All right, so here in this example, we've got 2 clear substances, and when you mix them together, boom. Not only do we have a color change, right, change to yellow, but you can see that it's a different consistency. It's cloudy, and that is the solid that's coming from the reaction of those 2 liquids. And so a lot of times a precipitate, it's not going to be like a solid chunk rock, like a dun 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 dun, poof, there's a rock in my test tube. The unfortunate, that'd be cool. That'd be really cool, actually. It's like you put two things together and boom, it's like magic. You get this rock. That unfortunately is not going to happen. What will happen is you'll get a solid forming, but it's just going to be in the form of a cloudy substance. If you then filtered it and dried it, you could see it's kind of like gritty, like sand, like maybe sand or something like that. But typically, when we see a formation of a precipitate, it's going to be a cloudy substance that forms from two previously clear liquids. All right, number 4 is a temperature change. And a lot of times we're going to be thrown in a thermometer to a lot of the labs and reactions that we do. And so, similar to this, baking soda and vinegar, you're going to see a temperature rise, a temperature change there. All right, or you might see the temperature go down. It's still a change, so a chemical reaction has definitely occurred. So any temperature change, all right, similar to color change, it has to be a change in temperature. All right, last but not least, the production of light. All right, glow sticks are a great fun example of a chemical reaction, an evidence of chemical reaction, a new product being formed because light is being given off. All right, energy in the form of light being given off. Another example of that is anything that is combusting or burning gives off light in different color flames. All right, so production of light. So that's the evidences of chemical reaction. So as you're mixing things together in the chem lab this year, look for these evidences of chemical reactions. If you see at least one of these, a chemical reaction has occurred. If you don't observe any of these, no chemical reaction has occurred. Okay, so it's super important to kind of realize that not every time you mix two things together is something going to happen. All right, it's kind of, a drag that it doesn't. But not every time you mix two things together will a chemical reaction occur. So you kind of got to look for it when it happens. So this is what you can look for. All right, that wraps up our introduction to chemical reactions.